Okay, so hi everyone, I'm Tobie, co-founder and CEO of SurrealDB. I'll be touching a little bit on what SurrealDB is briefly in this talk. But to be honest, in this talk, I want to look at three things. So first of all, what is SurrealDB and how does it have anything to do with MLOps? The second thing is a brief introduction to anomaly and outlier detection. And then a little bit later on, we'll be looking at a walkthrough of how you rapidly can iterate on real-time anomaly detection, doing that straight inside the database itself without using any external tools. And then we'll be building on that with machine learning models, again, directly inside the database. So what is SurrealDB and what has it got to do with MLOps? So SurrealDB is a multi-model database. We'll come to what that is in a minute. The difference with SurrealDB is we've separated the storage level of the database with the computation level. This enables you to have more transactional workloads if you want large number of writes, or more analytical workloads if you want large number of reads, and you can scale the different layers independently. In addition to that, it's completely ACID, so it's completely transaction-based, it's ACID compliant, yet it's designed for these hybrid transactional and analytical workloads. It has an SQL query language. You don't have to query it in SQL. It's a document database. It has nested objects, nested arrays, graph, functions, but you can query it using traditional SQL. You may, or similar to what you may use on a day-to-day basis. In addition to that, it supports multiple different models. One of those is bringing machine learning functions right inside the database itself. So not forcing you to use any other new type of framework. You can still use the frameworks that you use to build your machine learning models. You can then bring that in and integrate that within the database. It's designed for real-time data analysis. So you can mix and match these models together, graph, document, time series, and you can build them up into a single query and perform real-time analytics on that. And the final point is the machine learning that you do within the database. It doesn't happen by pushing off through your infrastructure, through third-party platforms, through third-party services. The model itself is brought to the data, and that's important for SurrealDB. At Surreal, we believe that everything is about data. And so bringing the models, the tools to that data is better than pushing duplicated data or any data that you may not need out to other external services. So as a summary, the models that we support in SurrealDB cross over from relational databases to document databases like MongoDB and relational like Postgres and MySQL. But we also support key value requests. We support graph, so similarly to Neo4j or something like that. We support time series. And then you can also do many other things on top. So you've got full text search indexes, vector indexes, as you've got in many other databases nowadays. Machine learning, as I mentioned, and then geodata as well, if you want to deal with geolocation-based data. The important thing with Surreal, you don't have to choose upfront which model you use. So you don't have to say, I want to use graph for this particular problem, and now I have to store everything in graph, and now I have to model my data in that way, but then for a separate project or a separate application, you have to use time series. In SurrealDB, you can start with document, you can start with relational, and you can build on that. So you could say, you can have a query that queries relational data with time series, with graph, with document, with a vector index, and it pulls it all together in a single query. And you're never duplicating out that data across those contexts and then comparing it in your application. The final thing about SurrealDB is the way we built it. It's built fully in Rust and it's open source. It's designed to be an embedded database, so you can run this within Rust, within Python, within Golang. It's designed as a single node server, so something like a relational database like MySQL. And it's also designed to scale to a distributed environment. So if you want to have hundreds of nodes running large-scale computations, that's where the separation of storage from compute comes and is ever more important. So you can scale out the storage as you need, and then you can scale out the compute layer on top for running your inference or running your mathematical analysis. Today, we're going to be looking at two main functions. The first one is QL, which is our query language. SQL is what we went with. The community was a bit perturbed by that, so we called it SurrealQL on the end. It's SQL-like, so if you've used statements like insert or select from traditional databases, it's very similar in SurrealQL. The difference is we've got far more built-in functions that you would find in many other databases and even in many other programming languages without needing to use packages. And we've obviously got support for different models. So we don't have joins in SurrealDB. We don't believe in joins. I never enjoyed working with them when I was using Postgres and MySQL. I haven't met a developer who really enjoys them. And we'll look at some of the other features it's got later on. And then SurrealML we'll be looking at a little bit later on, and that is the ability to bring a model, machine learning model, directly into your database and infer on it as a function right alongside your data. So what is anomaly detection? I hope most of the people in this room know what anomaly detection is. I'll summarize it anyway. So anomaly detection is outlier detection or novelty detection. It's the process of identifying data points, events, observations that deviate significantly from the expected or normal behavior within a data set. You've got two types. You've got univariate outliers, which is a single variable or feature in isolation, so effectively single dimension. This is temperature or humidity, which may be outside of the normal range. And then you have multivariate outliers. So this is a combination, effectively multi-dimension. You have a combination of variables or features, such as temperature and humidity, that combined make this point outside of the normal range. And the way that you approach these different problems require different solutions. So importantly, I think nowadays, everybody is jumping into machine learning. Jump into machine learning, and that is the way to solve this problem. And often, you hear it more and more, people have these systems that work, and they work for the problems that we've trained them on, and they work for the problems that we've tested them on. The moment you have outliers outside of those ranges as well, you then have problems, and that is effectively the black box model. A lot of the time, machine learning models that are being built, users don't necessarily understand how they're working or for what reason they're working. So a common pitfall in ML projects is to jump straight into machine learning. But in the case of anomaly detection, there are two approaches. So obviously it's beneficial to go to try this iteratively, to start with, especially if you're using or solving something like univariate anomalies, to actually use this in a more mathematical way. It's actually relatively simple and relatively performant to do this without having to use models at all. But then when you have more complex problems, such as multivariate anomaly, then that requires different solutions, and we'll touch on that later on. So in this really, really basic example, we're going to be looking at a real-time temperature monitoring for an IoT device, which regulates temperature for a manufacturing process. I just want to jump back a couple of slides to how SurrealDB can be run. So SurrealDB, as I mentioned, is a database that can be run embedded or distributed. So everything that we look at today here could be run on a massive cluster with 50 nodes dealing with billions of events, or it could actually be running on an iPhone device or on a temperature recording device built right in Rust or right in C. So every single thing here can be implemented exactly where it needs to be implemented, right next to the data. If that data is coming in before it gets pushed up to the cloud as an IoT device, it wants to be, anomaly detection needs to be processed. That can be done in exactly the same way. It doesn't matter how you deploy it. So in our example here, we need to stay in a certain range to ensure the best quality product. So it's therefore important to receive real-time notifications for outlying temperatures. So for example, today we'll be starting with univariate outlier detection using the interquartile range algorithm. We'll go from 0 to a production-ready system using just SurrealQL, not using any other third-party system. And then later on, we'll dive into multivariate outlier detection and how you can use SurrealML and machine learning models to do that. So before I go into the outlier detection itself, I have to first introduce a few concepts in SurrealQL that may be different. So the first thing in SurrealDB, we have tables. So here we're creating a person record with a random ID in the person table, and we're setting the name to Tobie. So this will create a random ID. It will be based on a random or UL ID, and that will enable us to scale with a number of writes as we distribute across a cluster. I should say create at the bottom. There is a special type in SurrealDB that you don't really find in any other database, and that is called the record ID. So person Tobie is a direct pointer to a single record or a single document within the person table. That ID is Tobie, and the table is person, and that enables us to go straight to that record without having to use a table scan, without having to use an index or anything like that. So they're doing the same thing, they're both creating a record. One of them is creating a random record, and one of them is creating a record of a specific ID. The second point, which helps to build on this, is we can now add graph relationships between different records. So the user Tobie record and the article Surreal record will now be linked with a graph relationship with the right record, which again is another table. So we could iterate through the right record table, we could iterate through the user table, or iterate through the article table as well. And then we can add relationships between whole groups of objects as well, or whole documents together. And the final thing, which is the most important thing for this tool, is something called record ranges. So SurrealDB is not a time series database, but the way that we handle these record IDs enables us to operate over data which may be time-based. So for instance here, with the very first query is selecting from person 1 to 1,000. So if there are 20,000 rows in this table, it's not even going to look. It's not going to look at the table, it's not going to look at an index, it's going to go straight to person 1 and straight to person 1,000 without that range of the table. That's very basic, but the moment you start to come to more complex queries, like the bottom one here, I want to select all from the temperature table, where the first, let me jump back a bit, IDs in SurrealDB can also be arrays. So they don't just have to be a string or an integer, they can also be an array of values. So here we've got London, the city name, as the first value, and the time as the second value. That enables us to very quickly and easily go to just a particular range of that table. So the temperature table still has all of the records, but I can now filter specifically from London at a particular time and up to London at a secondary time. So that's just, if there are billions of rows in this table, it's only going to be looking at 1,000 for London between date 1 and date 2. And then the final thing that you can do with this, which is very important in real-time analysis, whether it be anomaly detection or product recommendation or analytics in any form, is to be able to start from one of these records and then to process relationships out. So on the very last example here, we are purchasing, starting with person Tobie, we're going to traverse out to their purchase products. And then from those purchase products, we're going to find other people who have purchased those products. And then we're going to find other products that those people have purchased in the last few weeks. And then we're going to, that's effectively a product recommendation engine, real time in life. So we've got users using this for millions of queries every minute on millions of customers. And they're effectively doing product recommendation in real time based on graph and mixing that with RAG and vector data as well. So that was a deep dive. There's a lot more things you can do with SurrealQL, but those things are probably necessary for the next part. So to start with, we're going to create 10,000 records in SurrealDB so that we can try them out. So in SurrealDB, in SurrealQL, we have the ability to use for statements. It's very much like a programming language as well. And then we can use functions that we've got built into the database. So this is creating random strings, random UUIDs, random floats, and random integers. And you'll notice that the sensor readings table, we're actually using what is called a complex record ID. So it's an array of time and then a random float to generate those. So to pull out the temperatures in the last hour, we don't have to do anything complex. We don't have to build indexes. We don't have to do anything else other than pull from the sensor readings table the particular field, so the temperature Celsius field, but we want to start specifically only from the current time minus an hour. So we're just going back 1 hour and up to an hour. And this value here is a special value in SurrealQL, which effectively means ignore that value. It's like undefined. I know that's not the best thing to build into a programming language, but like JavaScript, it's like undefined. We've also got null. So that is effectively pulling out all of the last hour's temperature recordings. Now, then to pull out the the low outliers and the high outliers, we're going to use interquartile range along with the multiplication of the magic formula of 1.5. So here we're effectively using inbuilt functions. So SurrealDB has a large number of mathematical inbuilt functions for percentiles, histograms, interquartile range, and many others beside that. So effectively what we can do, we can subtract the interquartile range from the percentile here. We're pulling out just the bottom 25%. And then for the high outliers, we can do the same thing. We're pulling out just the top 25%. So this enables us to find as variables the low outliers and the high outliers for the entire number of records over the last hour. Now, what we want to do, we want to build on this and perhaps get alerts or notifications when we receive temperature recordings which are outside the normal range. So by adding if statements, we can now detect when something is less than a particular outlier, and that outlier can change over time as well. And then vice versa, the second example, when the outlier is, or when the temperature is higher than a certain outlier. So here, we're building on, I'll jump to the second slide first actually. We can use these events, these are triggers. So we can say when event equals create, so when a temperature recording is created. And then inside this code block here, where we say do something here, we can say if the value that was inserted was bigger or lower, or higher or lower than the high outliers or the low outliers, then we can do something with that. So for instance here, we're automatically marking the record, so update after.id with outlier equals 1. So 1 being low and 2 being high. We can then also use an HTTP function directly in the database to call an endpoint. So this could be calling a REST API, it could be calling anything else. There's lots of different ways you can connect. And that would enable you to push that data to an external system if you wanted to. You could push particular temperature Celsius, you could push the entire record, or you could push groups of records if you wanted to. So it can contain the entire outliers group. So the next step, building on this, is the ability. So everything I talked about before can be run on an embedded database. But when you want to listen to events as they come in the cloud, let's say, you can build on that with the live statement. So the live keyword at the beginning of this select statement, and this is very similar to what you might find in another database with select all from sensor readings, enables us to listen to events as they come in. So now we've built a trigger that enables us to detect when something is a low outlier or a high outlier. We can now listen to that, and when outlier is not empty, so when outlier is either low or high, we can now listen to that and respond to those events in real time, perhaps pushing off to another system, or we've got a system which is listening to that and building on that data in a certain way. We can then track and visualize that in a real-time dashboard. Now, the most powerful thing in SurrealDB is building all of this functionality together. So in this example here that I've shown you so far, we're really only touching on time series-based data and mathematical functions. But you could build on this with graph, you could build on this with vector indexes if you wanted to analyze things in a certain way based on vector data. Here we're building on that and creating a simple function. So instead of having to remember the mathematics every time that I want to build this, detect low outliers and high outliers, I can now create a custom function which does this all internally. So I can build up my custom functions, and that will enable me to just call a very simple function name with my variable data in it as well. Importantly, everything in SurrealDB is statically typed, so we can specify that we need to have data which is an array of numbers, and if it isn't, it will error. The SurrealQL in the database is kind of heavily inspired by Rust on the one hand and heavily inspired by JavaScript on the other hand. I know they're complete opposites, but we have a very dynamic object language, whilst at the same time having borrowed a lot of stuff from Rust about the static and the guarantees of the language. So multivariate is much more complicated. Being able to detect when something with multiple dimensions, 2, but maybe even more dimensions, is outside of the normal range which is much more complicated. And so even though I said don't always jump to machine learning, sometimes you have to jump to machine learning. So we've introduced an open source file format called SurrealML. It doesn't really do anything clever. Other than that, it enables you to package up your machine learning model, whether from PyTorch or TensorFlow or sklearn, and add some metadata around that model, and then bring that model into the database. So effectively, the SurrealML file is allowing us to describe the model, allowing us to describe the arguments that the model expects, and then allowing us to version it. So think a combination of kind of Docker and metadata. This SurrealML file can then, it's effectively text, it can then be imported right inside SurrealDB. So you have a pre-trained model that's based on multiple features such as temperature and humidity, and it's detecting outliers based on multiple dimensions. Those models can be uploaded directly into the database using this SurrealML file format. And importantly, the inference happens inside the database alongside the data on our native Rust inference engine. This can make it faster. You're not having to deal with external systems. You're not having to deal with the network. And yet it doesn't change the way that developers work with machine learning models. It doesn't force you to have to use something other than Python or TensorFlow or PyTorch. So a model in SurrealQL is imported in a similar way. This is a bit of a vague example because you can't really upload a gigabyte model in text format at bytes. But effectively, you do this behind the scenes using our command line tool. And it effectively runs this statement internally and adds the binary data to object storage. So you can connect to S3, and you could have S3 storing all of your models, and then those models will be cached as and when you use them on the nodes. Again, this can all happen in an embedded mode, so it could happen on an iPhone, it could happen on an IoT device, it can also happen in the cloud. Now, we've uploaded the elliptic envelope model, and we uploaded version 1.0. And the data we pass into that could just be an array or a vector of floats or numbers. And that's kind of the raw way of working with models in SurrealDB. You can go one step further, and you can actually pass specific metadata to the SurrealML file, which determines what arguments the model expects and how that argument might be converted from a SurrealDB value. So using a different example here, we've uploaded a slightly different example. We've uploaded an insurance prediction model. This is something that accepts a couple of arguments. So we're looking at whether someone has purchased a house property price before, a property before, the rounded value of the disposable income, and then the person's age. This is obviously very basic. You can pass in hundreds of arguments. Effectively, these get converted to vectors behind the scenes. So everything is still floats. Everything works in the same way that machine learning models are being built in the world at the moment. But it enables us to run this entire model as a function in the database. I don't have to push this out into a queue and deal with that queue and then deal with the response and push that back into the database, all using lots of different microservices. I can build the model using the developer pipelines that I use at the moment. I can then pull that into the database, and I can run that function right alongside the data as a function in the database. I could do that for a single record, person Tobie, or I could do it for every record in the database, if you've got the power to do that. Then you can build on that again. So everything that we chatted about before, in terms of events and triggers, you could then say, look, whenever someone's income changes, so when they're before income, the income that was before this event or modify the data, does not equal their after income, then I want to reassess and relearn against this user based on the model version 1. I want to push those arguments, the arguments of that user, into that model, and then I want to set the likely to buy field to true or false based on the change in their income. So SurrealDB has support for versioning in two kind of different ways. The first is model versioning. As I showed you, you can upload many different versions of those models over time, and gradually, as you're happy with the results, you could be testing them against your data in real time. As you're happy with the results, you could upgrade all users to the new model as and when it makes sense for the business. That makes every single step reproducible and auditable. You can go back to previous versions if you need to. The second thing that we've just recently introduced is the ability to version data itself. So effectively, SurrealKV, which is our native storage engine, again, it's open source, built in Rust. This enables you to go back in time. So I can go and say, I want to find all of the products that this person has purchased, but I want to do that as of 6 months ago or as of 12 months ago, because that data is more relevant to the data before the Christmas period coming up, rather than the data of the products purchased in the summer. So combining these two things together with SurrealKV and SurrealML, you're able to then say, what did this model look like on the data that existed at the time? And so effectively trying to mitigate around the black box effect, which is the data is changing over time and the model is changing as well. But I want to go and see exactly how results looked historically and currently, compare them together and then see what the best outcome for my model is as I build it, as I develop it, and as I improve it going forward. So that was as a summary of SurrealDB, SurrealQL, and a brief look at how to deal with anomaly detection with univariate and multivariate anomalies in SurrealDB. So any questions at all on anything?
First, thank you. That's a great idea, and I think you think for many dimensions in the real world. Do you have any test results or benchmark on your platform for us, and we can see it in the real world? What's the stress test, and what's going on if it have some pressure on real data?
Yeah, performance benchmarks for which aspect?
Maybe just kind of anomaly detections.
Yeah, so building a database like this, you get asked to compare yourselves with the outside world in so many different ways, right? The first thing we're actually launching this month, November, is benchmarking comparatively to document databases and relational database. But obviously, as a multi-model database, it's hard to compare yourself with every single different type out there. So, but yeah, we have lots of benchmarking internally. We have a question from our GitHub, which is, I want to run a machine learning model on every row in the table, which was just said in a few days ago. It's hard, right? Because that is effectively running a machine learning model against every single row that gets passed off to the GPU, the inference engine, and that can take time. If you're doing that over one record, that can take time. If you're doing it over 1,000 or 1,000,000, then sure. So it really depends on what the workload is. It depends on how your data is formulated, how many arguments, how many dimensions to your data as well. From a performance perspective, it also affects, are you running on a single node, are you running in memory, are you running on a distributed cluster? But from a performance perspective, SurrealDB is designed to be as performant as any other document or relational database, and then able to scale linearly as well. Awesome.
Yeah, it'd be great to just understand, what was your inspiration for this? And it seems like such a tough problem to solve. Knowing even where to start, how did you get started with it as well?
So we went open source in August 2022, and it took off, kind of overnight success, which is great. But actually, the development started in 2015. We were building applications on multiple different databases. So we were using Influx and MongoDB, and we'd use RethinkDB as well, DynamoDB, OrionDB. This is the same problem that many of you probably face today, especially as you work in large organizations, dealing with multiple different database types, database platforms, and then your application is having to communicate with one database, which is non-transaction based, only storing data in time series format, and then another one which is transaction-based or cloud-based or API-based, and there are just so many different ways of working with that data. The challenge you've got is how do you bring all of those different types of data together well in a performant way? And to build that, to work out how to do that, that was the hardest part. But I think I touched on record IDs, somewhere in the middle there. That record ID enables you to do so many different aspects. So it enables you to go directly to a record performantly. then to traverse out, so you've got the graph, it enables you to do key value, it enables you to do time series ranges. So even though SurrealDB isn't a time series database, it's not ever storing data according to time only. You can customize it, or you can make it as a developer work with time by putting time as the first ID in the record, and then you can scale and have those benefits as well. So it took a lot of time, it took a lot of experience over the years of working with many different databases. And yeah, the biggest question we get asked today is, all these specialist databases exist for a reason. How can it do everything? And that's something we're proving can be done as long as the model is, what we've built, the model is built in the right way.
I'm curious, just to follow that up, I used to build data pipeline, does it really save time? For example, when you do data normalization, you use one service to build that and you put data lake. So it's let's mean that, for example, I don't need to use data lake, I can directly use the DB that you show, or how does it work? What part is saved from data engineers day-to-day work?
Yeah, so data lake is obviously a completely different type of database, usually columnar based, and there are certain things you can't do in Surreal that you can do in data lakes, especially if you're dealing with massive amounts of rows, billions, if not more, of rows, where you're only looking at particular fields. When you're mixing potentially unknown things together, so you're trying to infer on data that may not have a particular structure or may not be related in a particular way, especially when that's real-time based, and that's where something like SurrealDB can come into play. So there's definitely not going to replace data lakes completely, but a lot of the use cases that we're finding our clients are having are where they want to do fast or real-time queries. They want to have a response in milliseconds based on the result of some related data, or some data related to a particular known record, let's say. And having that performed in a data lake can be done, but often, let's say in particular scenarios, you're basing data off the large batch analytics run from the day before or something like that. There are lots of different use cases, but it's the ability to bring those models together, and it's usually graph and vector or RAG and document data, and combine them together in order to get that real-time approach. So SurrealDB is definitely not columnar-based because we're analytical, and we're transactional asset-based, and therefore it would be incredibly non-performant to be storing data in a column-based way when you're inserting data like that. But yeah, so still use for data lakes alongside something like SurrealDB. It's more the real-time aspect and things like that where it benefits.
I think for the implementation, so you mentioned everything here is typically unstructured inquiries was supported, but as a user, I feel it's just natural to, at some point, to structuralize some of my data to reduce, for example, tokens where I'm querying or operating on the tables. Do you also support any thing between structured and unstructured?
Yeah, so there's so much to touch, or not, that you could touch on in SurrealDB. So SurrealDB is schema-less and schema-full, and it can also be mixed. So where you saw in the functions arguments, you could say, this argument is an array of numbers. It's quite a kind of diverse type system in SurrealDB, but everything can be schema-based. So you could say, I want to have this field as an array, and I want to have inside this field a set of objects, and inside the object I want to have the key field as a string and the value field as a float or a decimal. So you can completely structure it like that. You can also say, the way we designed it was, if you want to come from MongoDB, it makes complete sense. You don't have to push any schema against your data. If you want to come from Postgres, that does not make sense. So it makes sense to people from both sides of the spectrum. You can also say, I want a flexible field. So I've got a completely schema-full object here, or a schema-full flat table, let's say, but I want to have a logs or a metadata field, which is an object, an arbitrary object, where there's no definition. It may just be a JSON output from something. And so you can combine a schemaless field with a schema-full record or a schema-full row and mix and match those together. So yeah, ideally, you get developing quickly with schemaless, you work out what you want to build, and you apply schema to everything because that is the best way of doing it. And then you have more consistency of your data.
But can we visualize this like schemas? That's my question.
Visualize it in what way?
For example, like ERD.
As a diagram?
Yeah, kind of.
Yeah, you can do that. So we have everything in Surreal is kind of custom built. So we don't necessarily work with the native tools that you might work with, let's say JDBC, ODBC, and the tools you might use. But yeah, you can visualize that data. It's got GraphQL integration if you want to use that as well. We've got a user interface that enables you to visualize data, definitions, schema, records, everything.
You said it's open source, but do you charge for
Okay, so open source is a tricky one, right? We're technically not open source according to the open source initiative. It has no limitation on production use. So you can run this on 100 nodes in production, 1,000 nodes if you want to. What we limit it on is running a database as a service. So effectively, we don't want to get into the realm of AWS or Google or Azure spinning up a service, as you know, has happened with other databases in the past, and making whole business units out of that. But effectively, it's open source regardless of that very small use case for development, production, embedded, distributed, highly available scenarios, whatever it is. Yeah, it's open source.
Yeah. Are there any capabilities to write tests within SurrealDB?
That's an interesting one. There are no capabilities to run tests. I'd say what you could do, because SurrealDB can be embedded, so you could run this in continuous integration. So you can either spin up a server, let's say in continuous integration, or you could even say, I don't want to spin up a server, I want to have this literally running in Python. I want to run, if I've got SurrealQL workloads, I need to know exactly that these functions that I'm building work in a certain way. So you could deploy your functions into embedded Python, or SurrealDB embedded in Python, check that they're running and performing the right way in CI or in your dev process. And then that same scripting could be developed and deployed to a distributed cluster in the cloud, let's say. It would execute in exactly the same way. So that would be one way to do it. There's no testing in SurrealDB. That's an interesting one I've never heard before.